Hello there. In this tutorial, I'm going to discuss about OSI model versus TCP/IP model. So, when you discuss OSI model, the first thing comes to our mind is that OSI model is a 7-layer model, having 7 layers, but TCP/IP model having 4 layers. And the biggest thing which OSI model and TCP model is OSI model is a conceptual model, where the TCP/IP model is a practical model. TCP/IP today in this gen where we are learning and working on internet is all about this TCP model, and this is why it is known as practical model, because this is very much practical to send data through application layer, then transport layer, then internet, then network interface, and then the other devices which having network interface, and then via internet, transport layer, and back to application layer we are getting the devices, we are getting the data via devices. So this network interface card is like your NIC network interface, which is available in almost all devices whosoever having connective can provide the connectivity of internet. Couple of devices, the new gen devices, are not having NIC but wireless. They are giving connectivity or internet via wireless. So another computer, for example, this is a computer, and another computer which have connectivity. So via NIC, then via internet, that NIC is there, but that device needs to be have a internet or network access. Then via transport layer, which is transport layer, which is basically uh, responsible for delivering messages from a running process. Means there are either they accept the message or they delivers the message. Acceptance, for example, application send the data to transport layer, then transport layer accept that data, and via uh, UDP or TCP, SCTP, they send this is the features of transport layer. They send the data to internet, and then the internet having work to send the data forward via NIC, and then this via UDP of other devices, via UDP, TCP, SCTP, we are getting data through application layer, and then back to our system, back where we are looking to send the data. So actually, what the basic of this 7-layer or 4-layer thing, this these 3-layer application, presentation, session, is known as application layer of TCP/IP. In some of the documentation, this session layer divided means this half 50% session layer is known as application layer, and 50% session layer is also known as transport. Means this transport is there, and this 50% session layer is also known as transport of TCP/IP model. Since the session layer is a session layer of OSI model, is basically establishes, manages, synchronizes, and terminal connection between the computers. This layer is basically synchronized data, terminates the connection between the computers. It also set up coordinates, terminates interactions and dialogues between communication device. It provide either half duplex and full duplex services. So 50% thing, I'm not talking about all documentation, but if you are seeing the documentation of Cisco, they are saying it's a 4-layer thing, 4-layer model, TCP/IP. Even some of the documentation divide network interface between two. So they said data link is one, and physical and MAC address is one of the layer. Physical and MAC is one of the layer of TCP/IP. So some of the documentation said that TCP/IP having model having a 5-layer concept, but most of the documentation said it's a 4-layer. And you will find this application presentation as session. Whatever the concept of application presentation as session, it applies to application layer. So this application either represent the data, um, understand the data, and send the data into the path with synchronization, do a segmentation. They all do the application, then send it to transport layer, and then the whole process of transport layer will work. Internet, well, the connectivity of to sending data should be there. Either we are connecting with WAN on LAN, uh, or if you are connecting, if you are doing IP thing, then this networking will comes, the internet will comes. Uh, Even if your computer connected into the local network, then via ARP or RARP, this thing will sort out via MAC address. Basically, we are able to send the data. So internet work is there. So either you connect cable to another PC. That is also known as data, sending data. That is also we are doing. That is also kind of a protocol we're following, but that is when. So it doesn't matter whether it's going to a worldwide network, but you can have a network even in LAN. So internet connectivity is must to send data from one form to another, and the network interface, uh, the data link and physical layer having a work. So it's like it's the reason TCP/IP is looking more practical, because you will find this thing in common application. Yes, common. For example, this paint, we are transferring some data via paint. That is application. Transporting internally, we are transporting and some of the data via computer. Internet, yes, if I using this laptop and I want to send data to another laptop or computer, either I need a cable, I need a data cable, or I need either a wireless network like Wi-Fi and Bluetooth. So I need some internet connection. I need a protocol to follow, and then network interface. Every device having network interface, even Wi-Fi having network interface, and MAC address. So this is how we actually send data, and then other network do have or must have network interface, the physical address. Since then, how we able to send the data. Then internet should have internet, or have a WAN or LAN. And transport, again, it will follow the some rules, and then it will send it to application. Via application, the other user will able to crack what the data is. If you have an extension called txt, then until unless we don't have application, we can't open this txt file. We have to be know what this file is. So this is what the OSI and TCP IP model is all about. And just practically, TCP IP is more practical than OSI model. It's a conceptual model, OSI model, and lot many vendors who have started their own protocol. OSI model came with the concept, and because of that OSI model, now every device having only one protocol to work on. So hope you learned something about this basic conceptual video about OSI model and the TCP IP model. So thanks for watching.